Hi, welcome back. In our previous lesson, we talked about deriving the demand curves. Today, we'll be moving on to the information we can get from our demand curves. So, we remember that we had a utility function being equal to x raised to the power 0.5, y raised to the power 0.5, where we had our budget also as px multiplied by x plus py multiplied by y equals I, where this is the price of good x, this is the price of good y, and then this is income. Now, when we maximize this utility subject to the budget constraint, we arrived at the demand function for good x as I divided by 2px and for y as I divided by 2py. Now, what information can we get from this demand function? So the first information we can get from these functions is the law of demand. Now we have to remember that the law of demand suggests that there's a negative relationship between the demand of a good and the price of that good, holding all other factors constant. What this simply means is if the price of a good increases, the demand of that good will decrease and vice versa. Now to show this algebraically, if we start with good x, all we have to do is differentiate the demand function for good x with respect to the price of good x. Now, given our demand function, this will give us I divided by 2px squared. Now, we can immediately see that this is negative, which implies the negative relationship between the price and then the quantity demanded. So this is just a mathematical way of showing the law of demand, that if the price of a good increases, the demand decreases and vice versa. So we can do the same for good y by differentiating the demand for good y with respect to the price of good y. And then we're going to have I divided by 2py squared, which is also negative, implying a negative relationship between the price of good y and the demand for good y. So this negative relationship means that an increase in the own prices of goods will lead to the decrease in the quantity demanded, and then vice versa. The second information that we can get from demand functions is whether the good is a normal good or an inferior good. Now we know that a normal good is a good in which quantity demanded increases as income increases, and then quantity demand decreases as income decreases. So this suggests a positive relationship between demand and income. And then an inferior good is a good in which the demand decreases as income increases, and then the demand increases as income decreases. So this suggests a negative relationship between demand and income. So to show this mathematically, you will see that a good is a normal good if you differentiate the demand for that good with respect to income, and you get a positive function. But if the function is negative, then it's an inferior good, which means that anytime income changes, demand goes the other way. So let's start with good x. If we differentiate good x with respect to income, given our demand function above, we are going to get 1 divided by 2px. Because the price of a good is positive, this function is positive, which means that good x is a normal good. And similarly for good y, if we differentiate it with respect to income, we are going to get 1 over 2py. And just like px, py is also positive, so this is positive, which means that good y is also a normal good. So since the relationship for both goods are positive, then it suggests that both goods x and y are normal goods. So what this means is when income increases, the demand for these goods will increase, and when income decreases, the demand for these goods will decrease. Now, if we had solved this and arrived at minus 1 over 2py, for example, then you can say that this good is an inferior good. Now, the next information that we can get from a demand function is elasticity. So elasticity is simply how responsive the demand is to the change in the price of the good. We can record that the formula for point elasticity is if we have E equal to change in X divided by change in PX multiplied by PX over X, where we have PX as the price of good X and then X as simply the quantity demanded, which is represented above as our demand function. If we use calculus, then we can replace the ratio of discrete changes, which is this bit, with a derivative. We can rewrite this as dx over dpx. So it means that this elasticity formula can be rewritten as this bit multiplied by that bit. So we have px divided by X. Now let's put all of these things together. So we already saw when we were looking at the law of demand that whenever you differentiate X with respect to Px, given the demand function above, you're going to get minus I over 2Px squared. And then we're going to multiply this by Px divided by X, which is the demand function. So the demand function is simply I divided by 2px. So this can be simplified into minus I over 2px squared times 2px squared over I. So you can immediately see that this and this will go, this and this will also go. So eventually we have our elasticity being equal to minus 1. So this represents a constant elasticity of demand because the absolute value of this minus 1 is 1, which is a constant. Now the negative sign over here simply shows the negative relationship between the price of a good and the demand of the good as represented by the law of demand above. So this is all that we have on our lesson on information that we can get from demand functions. Our next lesson will be on income and substitution effect. If you enjoyed today's lesson, consider subscribing. Thank you.